Afterwards, when the dummy starts moving on the path, the tool center point of the end vector, in here we call it the tip, starts moving also. This is because, as you can see here, for the scene hierarchy, the path point and the tip point are linked together. To check so, double click on the tip and you see that it's linked to the dummy path point, and the link type is inverse kinematics. So as a matter of fact, the inverse kinematics solver of Vrep is used to calculate the joint angles of the 3D object of the robot. So what happens is, when MATLAB gives a velocity to the path point so it starts moving on the path, Vrep starts to calculate the joint angles automatically through its inverse kinematics solver. Now this inverse kinematics solver can be found in here. Go to Tools, then go to Calculation, Module Properties. When you open it, go to the inverse kinematics. In the inverse kinematics here, you can see inverse kinematics group, and this inverse kinematics group represents the inverse kinematics chain of the robot. So the calculation method used is the damped least squares. Here you can change the damping values and the maximum number of iterations used by the solver. Also, you can change the weights that are used for avoiding joint limits and for obstacle avoidance.